Welcome to the Site Evaluation and Moving the Point Coordinates training video. This video explains how to determine if a site is sampleable and how to move the point coordinates up or downstream when it is not. This video also discusses how to document sites that cannot be sampled. This information is also located in the 1735-2 Aquatic Aim Field Protocol on pages 15 through 21. There is a flowchart in the field protocol on page 15 that walks through the aquatic aim site evaluation process. The first step in the process is to attempt to access the point. In some cases, a sample location may not be accessible due to unforeseen conditions, such as extreme afternoon thunderstorms or washed out roads. The second step in the site evaluation process is to determine if the reach is safe to sample. Some obstacles may have been identified during office evaluation, but objective and transient hazards are usually not identified. These unforeseen circumstances include high water, steep terrain, and extremely dense vegetation. In addition to terrain, approach, or weather-related challenges to sampling, some sites may simply not contain certain criteria needed for sampling. It is important to note, though, that all the sites shown in these photos were sampled. Aquatic aim requires personal safety as the foremost priority, but as long as safety is not being compromised, it is expected that those collecting aquatic aim data do everything that they can to access and sample a site. The next step is to determine if the site meets the sampleability criteria. To sample an aquatic aim site, 5 of the 11 transects within a reach must be sampleable. These 5 transects, which do not have to be in consecutive order, must have identifiable bankful features, have flowing or stagnant water that is not impounded, be safely wadable, have water flowing below bankful, and be situated on BLM land. If a site does not meet these criteria, it may have to be rejected. Let's walk through several examples to see what these criteria look like in the field. Remember, there needs to be a combination of 5 transects that meet these criteria within a reach to sample it. Use page 15 in the protocol for help. This site has a waterfall that begins downstream of the point coordinates. There's no way around the waterfall because of steep cliffs. There are identifiable bankful features, the area above the waterfall is safely wadable, and the site is on BLM land. Is the reach sampleable where it is now? Yes, it is. Since the point coordinates are where the F transect is located, transects F through K, a total of 6 transects, are still sampleable and meet the sampling criteria. Major beaver activity has impounded 8 transects at this site. Bankful cannot be identified at the impounded transects. The reach is on BLM land. Is the site sampleable where it is currently? No, the site cannot be sampled where it is currently because it does not meet AIM field protocol criteria. There are not 5 or more sampleable transects in the reach. When situations like this arise, the point coordinates can be moved so that there are at least 5 sampleable transects in the reach. For reaches that are between 150 and 500 meters long, point coordinates can be moved a maximum of 250 meters up or downstream. For reaches greater than 500 meters, the point coordinates can be moved, but the original point must be within the new sample reach. Moving the point coordinates, however, shall only be done as a last measure. A reach should not be moved, for example, to avoid annoying vegetation or semi-difficult terrain. The point coordinates should only be moved if it's the only way to make 5 transects of the reach sampleable. On average, sites are moved 20% of the time. If the point coordinates do need to be moved, it is important that they are not moved any further than absolutely necessary. They should be moved up or downstream until there are 5 sampleable transects that meet the appropriate criteria. For example, this reach is partially dry. 8 of the 11 main transects are dry and 3 are wet. Upstream of the dry section, the stream is constantly wet. the point coordinates should be moved upstream. First, the point coordinates should be moved up 2 transects, because 2 transects will be added onto the top of the reach to get 5 sampleable transects. Measure out 2 more transects above K and move the K transect. Then, remove the bottom 2 transects and move A to the bottom of the reach. Now there are 5 wet transects and the reach can be sampled. In many cases, the point coordinates of a site will obviously need to be moved before the reach is set up. To do this, a GPS is used to estimate distances from the original point coordinates. For example, the point coordinates for this site are located on National Forest lands. The point coordinates should be moved towards the BLM land that is upstream. It is a smaller system, so the point should be moved no further than 250 meters from the original point coordinates. The GPS shows that the BLM boundary is 200 meters from the original point coordinates and within the 250 meter range, so the original point coordinates can be moved. To get 5 sampleable transects within the BLM boundary and moving the point coordinates as little as possible, transects G should be placed near the boundary and transects G through K will be sampled. In this example, the point coordinates at the site are dry. There needs to be 5 wetted transects in order for an aim site to be defined as sampleable. Upstream of the coordinates is also dry, but there's a spring that creates a small stream not very far downstream from the point coordinates. After using a GPS to estimate how far the bottom half of the reach will extend, it is determined that all of the transects land before the spring. The point coordinates are moved because the spring is well within 250 meters from the original point. Should the new point coordinates, which is also transect F, be placed at option 1, 2, or 3? The correct answer is option 1. Moving the point coordinates so that E is at the top of the spring is the least distance the point coordinates can be moved while still having 5 transects that are wet. In this example, the site is full of stagnant puddles. 5 of the transects in the reach intersect some of these puddles. Is this site sampleable where it is now? Do the point coordinates need to be moved? If so, how far can they potentially be moved if the average bankful width was 5 meters? Yes, it is sampleable where it is now, and the point coordinates do not need to be moved. This system can be sampled where it is now because there are 5 wetted transects and there does not need to be flowing water to sample a site. This stream is flowing very quickly and the location of bankful is unclear. This stream may be flowing at bankful. It is also unclear if the transects are safely wadable. Is the stream sampleable where it is now? Should the point coordinates be moved? If so, how far can the point coordinates be moved if you estimate the average bankful to be around 10 meters? No, the stream is not sampleable where it is now. The point coordinates should be moved because if a stream is flowing at bankful or bankful cannot be determined, it does not meet the criteria needed to sample an aim site. Since the average bankful width is estimated to be about 10 meters, the reach length would be 200 meters long, so the point coordinates can be moved up to 250 meters. However, if the stream is flowing above bankful, moving the point coordinates may not help and the site may need to be revisited at a different time when flows are lower. This stream has a fence across it with a private property sign downstream of the point coordinates. Staying upstream of the fence, the average bankful width is 8 meters. The reach is laid out upstream of the fence and transects E through K were placed. Is the reach sampleable where it is now? Do the point coordinates for this reach need to be moved? If so, how far? Yes, the reach can be sampled where it is now, and the point coordinates do not need to be moved for this reach. There are 7 transects that are sampleable that follow the AIM criteria. Keep in mind that determining land ownership is not always this easy, so maps that show land ownership should be carried at all times in the field. As discussed in previous videos, aquatic AIM sites are broken up into small streams, large streams, and rivers. It is important that a site is sampled on the same stream size classification that it was assigned. So, when the point coordinates are being moved, the inflow from tributaries should be noted because they could change the stream size classification. For example, the input from a tributary could make a stream that is classified as a small stream above the tributary into a large stream below the tributary. However, this cannot be determined in the field. It must be determined by looking at GIS layers in the office. So those collecting data should call their supervisor or the National AIM team for help if they come across the situation. The point coordinates for aquatic AIM sites that have been sampled in the past should not be moved. These sites should not be moved because trends for these systems cannot be analyzed if sampling did not occur in the same area. At all aquatic AIM sites where the point coordinates were moved, record the new location of the point coordinates and the reason why the original point coordinates were moved. In some cases, a site may not be sampleable and moving the point coordinates will not make it sampleable. This type of site is classified as a failed site. Failed sites are broken up into 3 categories: revisit, permanently inaccessible, and non-target. These categories are detailed in Table 3 on page 17 of the field protocol. A failed site may be classified as a revisit site if the reach cannot be accessed on the first try, but there may be a different route, a different vehicle, or a different time of year that'll make the site approachable. For example, a site may be marked as revisit if a landowner needs to be contacted in order to gain permission to pass through private land. A site may also need to be revisited due to long approaches or bad weather, which shorten the amount of time available to sample the reach. A failed site may be marked as permanently inaccessible because there is no way to make the site sampleable. This may occur because of access issues from a private landowner, unmanageable terrain, or severely dense vegetation. A site may also be permanently inaccessible because it is too dangerous to wade or boat due to extreme whitewater or steep drainages. Lastly, a failed site can be marked as non-target. Non-target sites are those that do not meet the target population that aquatic AIM sites are designed for. Non-target sites are classified as sites with fewer than 5 wetted transects, lentic systems, or rejected due to a map error. Non-target sites that have fewer than 5 wetted transects are classified as either intermittent or ephemeral. As discussed in the critical concepts videos, intermittent streams have irregular flow patterns and contain recognizable bankful features. Ephemeral systems have sporadic flow patterns, do not contain bankful features, and usually have upland vegetation growing in the channel. The aquatic AIM protocol is only used to collect data on lotic systems, which include streams and rivers, and not on lentic systems, like lakes and wetlands. So if a site lands on either a lake or wetland, it should be marked as non-target. A non-target site may be classified as a map error if there is no evidence that a lotic system has ever been present, or if it is located on a man-made channel, like a canal or irrigation ditch. All failed sites should be documented with a specific classification along with GPS points, photos, and comments on why the site was failed. The Special Situations video further explores irregular reach situations. This concludes the site evaluation and moving the point coordinates video. Please complete the quiz to review.